Hello guys, I would just like to say that in this video there will be a few cuts somewhere where I probably made a mistake or something or whatever, but yeah, you will find that there are a few cuts. This is not to hide anything. If you would like more information about this project, please inbox me or comment. I would like to see your views on this. But yeah, like I say, there will be a few cuts in this video. I just thought I'd let you guys know, because I did make a few mistakes in the progress of making this project, but that's making a project for you, isn't it? Alright, so I'll get on with this video. Hello guys, I'm starting a new project, and I'm not sure if you've ever seen it before, but it's basically it's a rotary subwoofer. Now the way this rotary subwoofer works, my design is based on the eminent technology TRW17, which is this. That's it there. It's a rotary subwoofer. Basically what happens is this spins as per, and these little fins here, they flap like this from side to side, and they basically induce a frequency wave in the air, and they work out better than the subwoofer because they move the air more efficiently, because they're spinning at a set revolution around about 700 and 800 RPM. Whereas a subwoofer, they can move the air quite well, but because of its design, it can only shift a certain amount of air, and so the subwoofer is good for higher frequencies. For when you say, for example, when you're watching a film and an explosion goes off, yeah, it's great. But if an explosion went off with this thing, it'll pull your house to pieces. As funny as it sounds, I've watched the videos. If you do your research and have a look at the videos, you will find that this is true. So I'm basing my design sort of on this. So I've tried to do a bit of research. I've done a lot of research. I've seen a few videos, but there's no really like DIY sort of, videos or helpful guides. So I thought I would make this one, and you guys can probably might learn something, or you might want to take the project up yourself. So this is what I started with. I bought a motor off of eBay. I will show you the motor that I bought from eBay. Was this motor that I bought from eBay. You can't really see it. It's a Tech Top. It's a 3-phase motor. It's not very powerful. There we go. It's getting into more focus there. It's a 3-phase motor, relatively simple. This end doesn't come with this. I'll get to that a little bit later. But yes, it is a 3-phase motor. The reason being is because I find them quite strong, which is really good for this sort of thing. With wind resistance, it won't slow it down. It's capable of 2730 RPM at 50 Hertz and 3280 at 60 Hertz. And the way to work this out is 1 Hertz is equal to 60 RPM, and that is basically how you measure the RPM. If you don't really have a like an RPM meter or something like that, I'm almost certain that that is correct. If I'm wrong, please let me know, but as far as I was concerned, that is how it works. It's 1 Hertz to 60 RPM. But yeah, this is a 3-phase motor. It's not big. It's, you know, my hand is kind of holding it. It's a little bit heavy, which is good, because that'll help with all the weight it needs to stop it from rattling. I took the fan off. As you can see, there is no fan in there, and the reason being is because it blew off, really. It went a little bit too fast and it just kind of like exploded, so I just took it off. But it doesn't really need it anyway for the speed that it's going. On the frequency meter, it's only going to be running at 11.6 Hertz, which equals to around 700 RPM. It may go a little bit faster, maybe 12 Hertz. But yeah, this is what I bought first off. I bought this, and then to run this thing, you need, if you're going to use like a single phase supply, which is very most likely, because you will be using it at home, or you can use it anywhere really, but this is what I'm going to be using this at home. So I've bought what's called a VFD, which is a variable frequency drive, and it cost me £45 on eBay. It's an Altivar number 12 from Schneider Electrics. You can see it there. It's reasonably powerful. It's capable of running this motor, which is great, because that motor is a 0.37 kilowatt motor, which is half a horsepower, it says here. It just tells you that it runs at 240 volts. But this frequency drive is capable of outputting up to 400 Hertz, which is ridiculously fast, around about 17,000 RPM. But yeah, it's really small. I was really surprised to see something like this, really small. It was relatively simple to put together, but like I say, it cost me around about 45 quid, but whether you can pick this up again for 45 quid, I wouldn't know, because I don't really do a great deal of research on these kind of things. I just go out and buy them and hope they work, and if they don't, well, I'm stuffed. But anyway, I've used, to connect this up, I've used a normal, just a normal 3-pin sky plug, and it connects in the back here. Excuse me. And you got your positive, your neutral. Hang on a second, what happened to the other one? Is it just those two that I needed? Must have been. I've got no earth. Well, yeah, it's just the positive and neutral terminals that I must have obviously needed to use. But on this one, to the motor, because it's a 3-phase output, it's a single phase in, a 3-phase out, I've used just the normal cable, 3-pin plug, and I just wired it up to work with this, and it's exactly the same. You've got your L1, L2, L3, which all three are live, and it goes straight into here. And if I take this top off, you'll basically see the winding. I'll quickly show you that. Okay, so I've taken the screws out. So you can see here, stupid light setup. Right, you can see here that I have all these connections. You'll notice that there's only 3 lives. There is no neutral and no earth. So don't ask me how it works. All I know is that it does work. And there's a screw in there. How the hell has that managed to fall in there? I better get that out, eh? But anyway, yeah, you can see there, that one says U1, that one says V1, and that one says W1. On this little on this box here, you'll see here, it also tells you which one goes where. So you know where to wire it up. And another thing I must know is that these 3-phase motors, or should I say the frequency drive, has what's called a carrier frequency, which is like a switching frequency. When you switch it on, this one was set to 4 kilohertz. When you switch the thing on, when you use it, say, I don't know, 0.8 hertz or 1 hertz, it's got like a really high-pitched squeal to it. And I couldn't figure out quite what it was, and then after a bit of research I came to the conclusion it was what's called the carrier frequency, and they said to change that to say around about 16 kilohertz, or the highest it will go, which it was 16 kilohertz, and that's what I did. I've swapped that to 16k. You can do that through the settings, and and it was fine. It's still there, but because our ears can't really hear 16 kilohertz, it's kind of like disappeared. So yeah, anyway, I bought that. That cost me 45 quid. And this motor cost me £50, brand new, which is great. But the only other thing about that is that I think the bearings are going already, and I've only had it for probably 2 weeks. But that's only at high RPM, you know, it's just them kind of things. But in the meantime, to get this thing to work, it needs a coil. And the way this thing works, I'll do a quick drawing, hang on. Is it needs some kind of voice coil. Okay. I've bought some paper down, and I haven't got a bleeding pen. That's logical, isn't it? Oh yeah, I do, I've got one here. Right, the way this works is, you've got your motor, okay, with its little shaft, right, and then at the end of this little motor you've got your speaker coil, your speaker, okay, and then you've got your little driver. The way the speaker works, right, is that when electricity is goes into a coil, okay, I'll draw another leg there, right, positive, negative, and you have like an iron core that goes through this coil, okay, it creates a magnetic wave like so. This is just a crappy diagram. I'm sure you'll get the idea if you know how magnets and coils and things work. I'm sure you'll understand. And anyway, so because this is happening and it's on what's called a diaphragm, which is, I'll quickly show you, this is the diaphragm. Because the coil is got a voltage going through these two connectors, it makes it move up or down, positive, well, because it's AC waveform, it makes it do that, which is called a frequency, also known as hertz, which is what we hear when we play music. When you switch on your subwoofer at say 20 Hertz or whatever, and it vibrates at 20 Hertz, which is 20 movements a second, you can just hear it but also feel it if you turn it up, and you'll see that your speaker rattles a hell of a lot. So yeah, we need this coil to move up and down for us. And because this thing's moving up and down, we use what's like a helicopter rotor, if you like. So you've got your shaft, okay, crappy little shaft. Okay, you've got your shaft, and on this shaft here, around about here, is this swash plate. This swash plate has a little bearing on it here, right? This bit doesn't move, but this bit has got like little ball joints, if you like. This bit is the moving part. I'll draw it out. Moving part. Right. On these little ball joint type things are little, like what's called in a helicopter, they're called control arms. Okay. So they go up like this to another little ball joint, which is connected to the rotor head, which will sit on the end of this with a pin that goes through it to hold it into the shaft. Right. Rotor head. Okay, on the end of this rotor head is a bearing, again, another bearing. And on the end of this bearing is an arm, if you like, with a hole in it. In that hole is where your fin goes. Yeah, and there's a pin through there, holds that in place, and this little ball joint connects to this arm, and when this slides up and down, because the speaker coil will be connected to the back of here. Okay, speaker coil. Right, as this moves up and down the shaft, right, it pushes this like that. And because that's pushing this, that's pushing this, and because that's pushing this, this thing can rotate to around about 45 degrees. Okay, I'll show you the full thing in a second, but that's the basic concept of this. This shaft will rotate around like that, but because this is staying still, right, and it has a bearing here, this is the shaft that goes to the motor, right? As this is spinning around, that can stay still and won't tear the speaker to pieces, and that can move up and down, thus moving this fin or fan blade, if you like, in this kind of motion whilst it's spinning. That's what creates the wave in the air. So that's the basic concept of how this is going to work. I'll keep that over there. So to get that to work, I had an old subwoofer. I had a Sony Explode subwoofer. Obviously I've modified this one. Your normal subwoofer or any normal speaker you'll obviously know what they look like. But this one was quite important because it's got hard, it's really hard, it's all solid plastic, that voice coil. It's got a solid, not solid, but a very strong diaphragm, which is great. And it's 1300 watt, so it's quite strong. And also underneath it has a hole, right, which goes right through. You can't really see it, but see that little shiny bit just down there in the corner? That is this plate here. If I shine this towards the light, you can see that I have drilled a hole through the center, which is just there. This hole is 5mm, right? If you're going to make this project, I drilled this hole, it's 5mm, okay? Because what I bought, the rotor head that I bought, let me just get rid of that and I'll show you, is this one right here. It was on eBay, it cost me what, $33.90. It's from RC Echo, and it's a fly-barless metal main rotor head with 5 blades. It was the only one that I could find, so that's the one that I bought. With 5 rotor heads, so that, yeah, that's the one that I bought. That's the basic concept of my project. Now, when I was making this thing, I noted that the motor shaft is about this long, right? It's 30mm in length, okay, and is 14mm. The shaft is like this, and it had I forgot what you call it. It had one of those things in it, in the head of the motor, which I didn't want. I wanted the original. I just wanted a straight shaft, but actually, hang on a sec. But actually, it worked out really well, and what I did was I took this out with a pair of pliers. It was quite hard, but you can take these out, and it leaves you with like a groove inside it. It was like a 20mm groove like this, and it's about, I'd say, probably 2 maybe 3mm in depth. It's not very deep, but it was great because then I could make this little sleeve, which I needed. I needed to make this sleeve. I went to an engineer's place or machinist, and I asked them to make this thing for me. It's a sleeve, and basically how that sleeve works is it's 20mm in diameter. Okay, I'll write that on here. 20mm, okay, and this is the motor side. I'll call that M, and we'll call this rotor shaft RS side, okay. This is just for simple matters. And what I did was I asked the guy at the machinists. Oh, and I also would note that this, oops, dodgy arrow, is 60mm. I asked the guy to draw me a hole 14mm wide, okay, and I wanted it 30mm in. because this is 20 mil and there's 6 millimeters left over, taking minus the 14, that leaves me 3 mil, because you divide it by 2, 3 millimeters between this part and this part. That's 3 mil, that's 3 mil. That makes up for the 20 mil. Right. Then I asked the guy to bore me another hole, 5 mil. That's 5 mil. That's for the shaft end. This is also 30 mil. Right. That means I can adjust it. For the adjustment, okay, oh hang on, yeah, because that's 5 mil, 5 and 5, well, 5 take away 20 is obviously 15. You divide 15 by 2, that will leave you 7.5 mil each, or from this part to the end of the shaft is 7.5 mil. That's just if you needed to know that. So I got this shaft. Then I asked him to bore a hole 5 mil in, 5 mil in, for a grub screw. Right, that goes there. And then he threaded it. And then the same for this one, 5 mil in from the end, 5 mil. There was a grub screw here, or grub screw hole here, threaded. I can't quite remember what size the guy said, but it's only 2 mil. I'm pretty certain it's 2 mil grub screw, so it's not very big. It's quite small. While the guy was doing that, I went to B&Q and I picked up a few little bits. I picked this piece of wood up. The guy gave it to me for £1 because he's a great guy. I only needed a small size sort of base. This will be my base for the box, for the motor. The motor will stand about this high. But I'll come to that a little bit later. But this pallet, if you like, is, let's see how wide this bit is. That is 27 centimeters or 270 mil, and this side is, there's your 30 mark. 30, I'd say that's around about 35.5, maybe 40 centimeters or 400 mil if you like. And I had a set of old speakers, so I got these. If you're gonna place this thing on carpet, this is great, because they seat it to the floor. They're like pins. Basically, they just screw in. I'm yet to file those, but they just like screw in. There's a screw inside there, and then that tightens this down. And you can take these off. You can take those off. It's just like, it looks like a little bit of a bullet head. There's a screw in there. You can pick these up off eBay for about £10 for probably 10 or 8 or whatever. I already got mine for free because I had them on a speaker. This wood, I would also note, will resonate the sound of the motor. So what I'm going to do is I'm going to get some rubber, just like probably 2 mil of rubber, and just lay it on top, screw it in, 6 screws, 3 on the top, 3 on the bottom maybe. Probably 2 more, 8 screws, and that will just dampen the sound of the motor. Hopefully it will do that. I know you should isolate them fully, but this resonates motor sound. So that's what I'm going to be using. Okay, this is the rotor head. I already made this, as you can see, and I do have the drawings for it, guys, so don't worry. This is the rotor head, as you can see it there, and I'll show you just quickly the basic concept. Just bear with me 1 second. Okay, so don't worry about this piece of blue tack. That's to balance this thing, because it was slightly out of balance. I've bought here this is 1mm perspex sheet. I bought it from eBay. It cost me £6, I think, for the two. I bought two A4 sized sheets, and they did pretty well, with some left over if I needed to make another one because I broke it or whatever. It does look a little bit flimsy, but it's not that bad. It's really not that bad. Oh yeah, and this, if you do buy this particular rotor, it will come with 5 blades already. It comes with 5 of its own blades, helicopter blades, which are like, they come out to about here, they're so long. And what I did was, because this is only 1mm, the gap here, this gap here, where you fit the blade, is 5mm. So what I did was, I just got those helicopter things, those helicopter blades, and cut the end off, because it's already got a pre-cut hole. So I just cut the end off, and filed it down a mil, and slotted these in, bolted them down. And you do have to bolt them relatively tightly, because there's only one hole. If there was 2 holes, it wouldn't have mattered so much, because the blades wouldn't do this kind of thing while it's on it, and it doesn't need to do that, because if it does do that, it'll make it out of balance, which is why I put this blue tack on. I've probably got a blade out of balance somewhere. So yeah, you do have to tighten these down pretty tight. Once I've got this all set up, these are going to be like glued with some super glue just around the sides, once it's all set up. But anyway, the basic concept of this is that the shaft spins like this. Okay, it's not attached, so all of it's moving, but this thing here, this is the bearing. Okay, that bit stays still but moves up and down like that, and that's how, if you can see it, that's how this thing actually works. Okay, so that's spinning like so, and that moves up and down at the same time on this bearing. The drawings for those blades, I know you want them, are here. I made a new propeller. This one is slightly wider than the other one, and I think it's a lot safer than the other one as well. This one uses 2mm perspex instead of 1mm, because the 1mm wasn't very strong. So yeah, if you put a sine wave through that, yeah, it was great, it rattled a lot, but because it's so thin, it just flexed in the air, didn't actually push it. So yeah, it kind of wasn't so great. So 2mm is quite thick, but obviously what comes with thickness is slightly heavier, so you have to be really cautious. But anyway, this is the new design. It's slightly wider as well at the tip. Instead of 3 inches, it's 4 inches at the top. Same width at the bottom, 40mm, with your 15cm hole there, at 15mm hole. You may find that this hole maybe is slightly too high. You might want to adjust it a couple mil, but that's just trial and error. Me personally, I'll just use this as a template to cut out the material and drill the hole where it says, but I find it sometimes it's a little bit too high, so I just drill another hole just directly below the other hole and hope it fits. And if it does, that's great, because then I can use it. But anyway, yeah, the dimensions are on here. You can see there. It was originally 2 straight lines up like this, okay, which is why here you can see that it's been measured and stuff. So this is 7.5 inches straight line. I used a protractor. What I did was I made a straight line, just any single straight line that was 40mm, and found the halfway point, and then I got my protractor, because it's got a straight line in the middle, and lined it all up. Then I was able to mark it. You can see the little mark there. Then I just drew a straight line from this mark at the bottom right to the top. That made it 7.5 inch. A centimetre down from there, I got my protractor again, and then just drew a straight line straight across, and that's where I drew my corners. That is basically what that bit's for. It's just so I can do my corners. 1 centimetre in from the edge is where the sharp corner should end, but oh, hang on. But it should still keep curving around to the centre. Same for the other side. At this point here, which I'm not sure if that's another centimetre across from the other centimetre, which would make that 2 centimetres, or was that 30 centimetres from this? I think it was 30 centimetres from the centre point here to the edge. So 30 centimetres this way, 30mm, sorry. And here, from the top line straight across, because there was a line that went straight across like this, that was the edge of the 2.5 inch. That line that went across there. That line, there was a 2mm. I did a 2mm space, and I put a little dot there, and that was where that's like where my curve should go. It's like directing it a little bit to the center, just kind of curved it around. As soon as it hit the 2mm mark, I knew that around that area is where I needed to start cutting my corner, because I did it here as well. And the reason why I did this was because I knew that if I went around like this, if I cut a corner, sharp corner that was supposed to be 1 centimetre up, round, sorry, and then I just made it to the centre, I would be guessing all the way around, basically. So I wouldn't really have like a perfect, like, semicircle kind of effect, which is what I wanted. So that's why I put that 2mm there and that one there, because then I knew that around about halfway I was on the right kind of path, and then I can direct myself from there to here, and then from here to here, and then round. But yeah, it's 7.5 inches from this tip there right at the top to here. This point right at the bottom is 7.5 inches. This gap here, I think that's 5mm, and the same again, 5mm here. From this point here to that point there is 5mm. This bit here is 2mm, and then there's another 2mm space that goes upwards, and then when it gets to this halfway line here, this 5mm line here, I then start going around. But yeah, that's a 2mm gap there, or 2mm step if you like, and then it kind of like goes at a 45-degree angle, say for example, if you like, up to the 5mm point, and then it goes round. This is a piece of card. You're better off using card than paper, because then you can draw around it better on the perspex. Also, to note, if your perspex sheet, mine is here, if your perspex sheet has a plastic cover over it which is see-through, you're better leaving that on to draw your template on than trying to draw on that perspex, because the plastic will give way to the pen or pencil, whatever you're using. I use the pen. It will give way to that and will happily let you draw on it. Whereas trying to draw on that thing's like trying to flipping draw on water. It just don't work. Once you've cut it out though, always compare the blade to the template. Don't just assume that once you've cut it out it will fit and it's the right size, because it's not. Make sure that once you've cut it out, you take off all the burrs, because that's what I had to do. It was just full of crap. And then you compare it to the template, and you may find that there are some bits that need cutting around, or it is too small around certain parts. If it's too small, chuck it away, don't bother with it, start again. You cannot risk having that thing being outbalanced, spinning around at that kind of speed. It's just not worth it, because something will give way. So yeah, if it's too big, minor detail, just get like your the thing that you cut it with and just give it a bit of a shave. And once you've done that, make sure you go around it with some sandpaper to get rid of all the sharp edges and stuff. Because if you don't, like if you've made a small mistake and it's quite a sharp like indentation sort of thing, when that thing's flapping around, that will become a fracture point and then it will just pop. So if you get your sandpaper and you rub across all the edges, all this sides, around the corners and that, make them all smooth, you won't get this sharp jaggedy bits. You'll just get a smooth surface, so there is no fracture points, or if there is, it's so minute it doesn't really matter. But yeah, you have to I'm just saying, you have to be really careful with these things, because spinning around at that kind of speed, it's blown up on me twice already, 2 or 3 times, where I've had like bits of perspex just shatter. Maybe that's because I've put it into overdrive or whatever, but yeah, and yeah, that's it. And another thing is, once you have got it going, I have learned that don't try and pump it too much. You only need a small amount of volume to get it flapping. If you pump it too much, it's just too much for the perspex to handle, and it'll pop in no time, which is not great. So yeah, like I say, that is what you need to do. So yeah, this speaker here, I haven't quite finished this yet, but this speaker, what I did was, because it had like a plastic housing over it, I just unscrewed it, polished it all up because it looked like crap, and what I did was, to polish this without getting any bits in, I just blocked this bit up with tissue, and I used a power file just to file that off. And I can take this off now, but you can see them already, the little holes. There's holes in there. Hang on. Oh god, I should do this a little bit later. I'll do it a bit later, but yeah, there are holes inside this. There you go, look, you can see the holes. And yeah, so as I was saying, this is the general idea anyway. Let me just get this to go in the center, bear with me. There we go. Okay, that is looking good. So that sits on there. That hole was already there. It came with the shaft. This is the shaft hole. That hole there. There's a pin that goes through that. You can just see it there. Look, until this camera decides it wants to focus. Yeah, that goes in there. And that's what provides the torque. The torque goes through that pin and spins that. What I'll do is I'll quickly set this up and you can just have a vague idea as to how this will work. So what I'll do is I'll connect this up and you'll be able to see. I may also add this hole that I said is 5mm. It is 5mm, but it needs to be slightly wider, so I'd say probably 6.5mm maybe. It needs to be relatively wide because it's catching on that shaft, which is also 5mm. It's quite a tight fit. So what I'll do is I'll probably just get a drill bit and just go around in a circle like that, make it a little bit wider. Anyway, I'll set this up. Okay, let me just quickly go through the balancing process. To balance this, what I did was put this on here. Just put this rotor blade on here. Oh God, what have I done? Right, just like that. There we go. Right, what will happen is that I know where this goes, so I can take that off. Look, you can see already it's moving. Right, the bottom, which is the heavier part, will always go to the bottom. Right, if I put that up there, it's coming back down pretty quick. So this part of the blades, they're quite heavy. So what I did was I got a piece of blue tack. This is just a temporary measure, and I'll just put it right on this one, and you just keep building it up till it's right, and I should be able to spin that and it won't fall back down. Okay, that's how I did it. So yeah, I'm just gonna put, because what happened was, see that hole there where I said the pin goes? Yeah, kind of broke that. So I've got to use my ingenuity and use something else. So I'm going to use something else, and I'll show you how the basic concept of this thing works. Okay, this has already been set up. If you do get this particular model, I can give you a little bit of advice on how to set this thing up. It did take me a while to set it up because I could only get it up to 60 Hertz, but I wanted it to go higher. I can get this like right up to 400 Hertz now, but I don't want it to go 400 Hertz because it won't work. Why is it taking ages to go down to the bottom? Just go down to the bottom. Just go down. What's going off with it? There we go. It's going up now. Oh dear. That's not very good advertisement, is it really? Right, so this is 11.6 Hertz. I've set it to acceleration, set its acceleration to start up very slowly, so I can gradually get this to go to 11.6. Let's close that and click the run button. Okay, this is or what we think is 700 RPM. It's very, very quiet. It's very quiet. So as the speaker goes backwards, that's what it will do. As it goes forwards, it's blowing stuff around. It's really windy. Okay, that's basically how it will work. It's very quiet. It's a little bit wobbly, that's because it's not attached to anything, so, and I'll show you why it's a little bit wobbly. It's because of this little piece here. That is because it's not only like a temporary thing. I haven't fitted this, but this part that goes on the shaft like this. That bit goes, it's got a little hole in it. That bit goes onto the thing. Let me switch that off. I'll show you. It goes onto, there it is there, look. Goes onto that hole there, that ball joint there. Basically that keeps this bearing and the shaft in line so that it doesn't twist like this. It's supposed to be straight like that, and that's what this thing does, but I haven't fitted that, obviously. So basically that's as far as I am right now. So my next step is to get some rubber, get a few bits and bobs. Actually, I'm going to the workshop today. I'll go to the workshop today, so I can get a few bits done. I've come quite a long way with this project, pretty quickly. I'm really pleased with the output and the help of eBay users, getting all these bits relatively cheaply, which is great. So yeah, that's as far as I am right now. So my next step is to build it up. I could probably get it done today, actually. I might try and sort something out. But anyway, yeah, I've got to build a plinth so it sits yay high. Get some rubber. My family are all horsey fanatics, and so my uncle's a mechanic. He's built his own horse box, and they used rubber for the floor mat, so I'm gonna probably try and rob him of some flooring, so I can use that for some damping. Get that sorted, get it built up, see what I can do, see if it works, and if it works, it's going to be incredible. Once I've built it all up, once I've built the actual mechanical side, what I was going to do was, the way this works is you can't just stick it in a box, right, and expect it to work like your normal subwoofer. You can't expect that to just, it won't work in that kind of thing. What it does is it grabs a volume of air from another room, which is how it works. It grabs, say for example, you've got your living room here, your kitchen. This is where I'm going to put it, but it grabs the volume from this air from in the kitchen and pushes it and pulls it into the living room. So what I was going to do was I was going to measure the door. Okay, I'm going to measure from here, oops, from here to here. Okay, measure how wide that is. I'm going to use 15mm sheet, right, which will fit all the way through this door. Okay, and then I'm going to cut it in half, right, and then in between these two halves are going to be a joint, so I can fold it away and put it wherever I want to. So I can fold this away. Okay, in the bottom half, okay, you got your 17-inch hole, right? And the way this thing is going to sit in between the door is on this side of the wood, okay, are going to be like baby gate clamps, if you like, where you can just clamp it. You just twist the clamps and the clamp to the door frame. That is how it's going to fit. It's going to fit between the two doors like that, top and bottom. Baby gate clamps, or I'll make some clamps of some sort. And because it's sealed off, because that room is sealed off from this room, the listening room, and the sub will be in the volume room, if you like. What it'll do, as it's flapping around like this, it's pulling volume of air from inside the living room into the kitchen, and then when it does that the other way, it pushes the volume of air back into the living room, and it does that repeatedly at however many hertz. If it was in a box like this, you could probably hear it, but you'd hear more fan noise than you would like any kind of low frequency levels, which is what you're supposed to feel, the low frequency, not hear them really. Like, you know, for example, when you're watching Transformers, something blows up or whatever, and you get that, you know, it shakes you around a little bit in the cinema. Well, a cinema's probably got 2 or 3 of those, and look how big the room is, and you can feel that, and it's only probably got 2 or 3. I'm going to be using one in a tiny room, so imagine how that feels. And you remember, you know, it's 17-inch, and the faster this thing goes, right, the faster this thing goes, the harder hitting it is. But you can't have this obviously spinning, let's say, like 2000 RPM, because it'll just spin itself to pieces. There's too much force on those little plastic flimsy things. So yeah, like I say, it's not nothing special because it's a home project, you know, but it works, and that's the great thing about it. It's achievement. It's just something to do. That's what makes people happy. Achievement, you know, do something good you've achieved. So once this thing works, if it works, I'm hoping it works. If it doesn't work, then yeah, fair enough, I'll use the motor for something else, probably like for blowing up or whatever. But yeah, I'm pretty certain it'll work. I've just got to make probably a dampening box. This will go at the bottom of the back of the box, the end of the box, and then the door thing. In this little box here will be like, oh, what do you call it? It's like pillow foam, cotton, whatever it is, to dampen the noise of the fan. I might do something like that, but as a first project, I might just stick a hole straight through this piece of wood and get it over and done with, and see if it works. And if it works, then it's great. Then I can start thinking about sound dampening. But until then, that's a later. All I want to do right now is just get this thing working. So yeah, right now it's a working project, and it's going pretty well. I've broken a few pieces, but I've managed to get them all together and learn how to care for them. So yeah, that says ready. It's set for that. But yeah, switch that off now. So yeah, takes a while to switch off that. There we go. Yeah, it's a work, like I say, it's a work in progress. I've been doing other things, so that's why I haven't got around to doing anything else. But I'm going to take this down now to my uncle's, get a few bits sorted out, and hopefully we can get this thing going, which would be great. So yeah, I'll cut this video now, and I will continue another day, maybe. This is it. I've managed to get it running again. I've got some acrylic cut up, but this is what I mean by the test. This is test phase. Hang on, let me show you. Hang on a second. Get it working properly. A little bit more speed. Look at the door frame. Don't know if you can see that. The actual frame of the wall is shaking. Oh, it stopped. You see it? It's not going fast enough to keep it up, but there we go. You can just kind of see it's blurred out. Hang on. You get the general idea. Look at that. Can't really feel it on the door, it's not in a proper position, but if I turn it around it'll work better. But the door frame is shaking like mad. Hello guys again. Just another bit of an update, I suppose. I've managed to get some material cut so I can mount this thing on. Yeah, so obviously you'll need the measurements for this. This panel here was 40 by 400. Was it 40? Let's have a look. I'm sure it was 150, I think it was. Yeah, 150 by 400. I know that it's 400. And this is made from it's galvanized steel. And I went to a engineer's place, another one, and they folded this for me and cut that other piece of metal there. It cost me about 25 quid altogether, which was bro. So this leg here is 40 mil, and then goes all the way to here, if you can see that, which is 185 mil, and then across is 150. Same with this leg here. That's 40 mil, and from here to the back is 200. I'm almost certain. Or is that 100? No, hang on. Yeah, that's because there's a gap there, because the motor's kind of like sat on those at the minute. I'm just marking it all up. That's 200. I've drilled some 8mm holes for the motor. Hang on a sec. There you go, look, 8mm hole. Basically, to mark those up, all I did was I aligned it with the speaker. Put the speaker on the back here like this, slipped it on. Okay, and then I got this fan piece, which has been modified. I'll put that at the start of the video. But I put that on there like this, and I lined up those two holes there. I've made a slightly bigger hole there too, because the original pin broke. So I've just drilled a 2.5mm hole through there, so I can fit some bolts in that I bought from Maplins. I line this up anyway, and the speaker cone fits right there on the back end of this, and that left me 91mm, I think it was. That between here and this here is 91mm. So I measured 91mm, took that off. Sorry. Yeah, I measured the space between here and here, which was 10mm. But if I put a ruler on here, put that on here like this. Okay, and I'll get my other ruler. Because it's a cone shape, there's 10mm missing. But then I thought, well, because this ruler is flat, there's a gap just there. So I took off a mil or two and made that 91mm. So I measured 91mm from here to the fan swash plate, and then I got my pen and I just went like this, marked it here, marked it there, right, same with all four corners, and then I got my pen and right in the middle of here, just went like that, line, in the middle of this, line, same with all four, and then what you end up with is this kind of, forget these paint marks, you end up with these little tabs here, you can't really see them properly, on all four. Then I got a ruler, and then I went straight across with this ruler all the way to the other end of the marks on the other side of here, where the other holes are. And then I drew a straight line straight across, and the same with the lines here and here, these little tab marks just went straight across like this. I lined them up, there's a little tab there, there's that little tab there, you can just see it. Okay, and then I just drew a straight line straight across, and then I ended up with these lines here. That one went straight up there, that one went straight across there, you can just see the line there. Yeah, and then that gives you a little, it crosses the line, where the line crosses is where you need to drill. I drilled an 8mm hole through there. I'm just getting on to mounting the speaker on here, and as like I said before, fortunately this speaker or driver unit, whichever you want to call it, this driver has a hole in it. So what I did was I got some paper, Exhibit A, and then I put it on here this way around, like that. And then I drew around it, okay, drew around it as you do. And then once I did that, I put this to a pair of scissors and cut it out. Then what I did was put that on here like that, hold it in place, and then I held it like this, and then where the holes are, if you feel around like this, you'll feel there's a hole, and it leaves you a little mark when you rub it into it. And then I just got my pen and just dug away at it. And then I did that with all 5 holes. And then in the middle, what I did was, if you rub like this, rub the ring as you do, and it gives you this like circular outline. And then in the middle, I just got my pen and just put a tiny little hole in, which was roughly around about 5mm. I just poked it. So then what I did was I put this motor back on here, and I haven't had a chance to screw it in. So all I did was I just put the motor, hold on a second, on here. I just need to put this thing back in. Bear with me one sec. Yeah, all I did was, because I haven't put it in, I just put those 2 things in, some screw bits, and then I just shoved the motor to the base like that. Then what I did was got this piece of paper with my tiny little hole in it. You can see I've torn it out there, but put that on there, and it sits on here like this. Then I just kind of cut my way through, and it sits on there like that. That'll give you the template of where you need to drill your hole. So that's what I'm going to do now, is I'm just going to excuse me, I'm going to put those to the base again properly, circle my holes, take that back off, drill through it and see what happens. And then once I've done that, because now I know where this is roughly going to sit, I can just get my pair of tin snips or like a circular blade or whatever, just cut around there like this, smooth it out, make it round. The distance of where this piece of plate goes doesn't really matter. You can have it to the floor, you can have it up here. It doesn't really matter, to be honest. The only reason why I left it up here was because some airflow can go through there, and it gives me a lot of space up here to use it. Or if I just wanted it to the floor, I've still got quite a lot of room up here to play with. And I can just smooth off the corners if I wanted to. But yeah, that's I just tacked those on. They're not. I might TIG them on or fully weld them. I don't know. I think I might TIG them though, make them look a little bit more presentable. But yeah, and then I'm gonna drill some holes down the feet, 3 on each side, I think. What the hell's that on the camera? Hang on. What the hell's that? I think I got it. Yeah, and then hopefully once I've done that, I can get it on the base and try and see if it works, hopefully. So that's it for this part. I will get back to you with some more information once I have finished. The project is complete, and I know the last time you saw this it was in bits, so I'll just go through what I actually did. So last time you saw this had a really long piece like up here somewhere. I cut that off. I've welded it all up properly now. You can still see the tacks on there, but underneath, don't know if you'll be able to see it actually, underneath it's all welded up. Just all welded. Terrible job. With the piece that I cut off though, I made these. There are no measurements for this because I just cut them off and welded them on. And the reason for that is because when this is flapping around like a wet fish, it kind of like flexes this around. So yeah, it was rattling around a bit. So I kind of cut that down, and with the bits, used my resourcefulness and made some pieces to hold it steady. And you have to be really careful, because otherwise, if it's in the wrong position, your cone will rub a lot. This cone rubs a lot as it stands. It's quite. If I push this back, it'll stay there. It is a little bit stiff, but when it gets moving, it's free. I'm not sure if I mentioned before. To glue this onto here, I thought hot glue would do it, and how wrong I was. That is resin. I just got some $2.99 resin from flipping JTF, and just mixed it all up and dumped it in there. And just be careful not to get it down into that little gap there, because otherwise you'd end up with a solid rotor and it won't work. Another thing before I start is I ordered some spare parts. You guys, if you're going to do this project, you will need to order a few spare parts, and these are the main spare parts. I bought these. They are Trex 450 Pro ball links. Okay, I bought them. I think they were $2.99 or $1.99 each, and you get 10 in a bag. So I thought, oh, why not? I bought 2. So I bought 2 of those. You will also need probably some of these M2x20. You don't have to have the socket button head type ones like I have. I just got these because I thought they would go better, but I bought those. You'll also need one of these I bought from Maplin. 180 pieces. Well, you won't need that many, but I only really bought it for the the 2.5s, because the 2.5s fit like here. See that there? That the original one broke, so that is one of. Oh no, wait, no, that is one of. That's one of these. One of those is that there. That screw here. That originally broke as well, so I replaced that with one of these. The only thing is with this is that hole that goes through, I had to re-drill. I had to put a 3mm bit through that to get that to fit. And also the shaft, this shaft here. Remember how I was saying that was adjustable on here? It is no longer adjustable, because what happened was that the grub screw that was supposed to hold it in wasn't worthy enough of holding it in. It just kept getting loose. So as I was welding all this together, well, yeah, I welded that too, and it's fine. I've also, as you can see, there's 2 original wings. The other 3 had broke. Yes, I had to make those again. I must have made about 20 so far. I must say that this is a very dangerous project. I haven't had any injuries. Well, I say I haven't. I cut my finger, but that was when I was in test phase. I was just playing with it. So far anyway, but yeah, it's not designed to play music. I must reiterate, it's not designed to play normal music. It's designed to play music, for example, like classical music, when you're listening to it in a theatre or whatever, and this guy's got his, I don't know, his big bass drum, and it goes and it rattles like hell. Because it's for low frequencies, not high frequencies. If you put a high frequency through this, everything will just loosen up. and it will just dissipate in seconds. So you must tighten up everything really, really ridiculously tight without trying to round the heads off of anything. You have to make them really tight. Here, these little joints, I tighten these up, and then I tighten the heads up with a pair of pliers. Just got some pliers around there, around this little head, and just tighten them up. And then at the bottom of here, I just put a drop, and now literally a drop, because of super glue at the bottom, just to help stop them from loosening up, because they started getting loose as well. One of those snapped, so I replaced that too. Oh dear. But yeah, all in all, it does work. So I'm going to turn it around and put it on, and then I'm just gonna, I know I shouldn't, but I'm gonna put a track through it, and you might be able to hear it, I don't know, but I'm gonna play around with it. So let me just get this sorted. Okay, so I'm gonna set this to, oh dear, I'm gonna set this to 20 hertz. Not 20 hertz. What's it set to? 18 hertz at the minute. Right, that's motor speed, by the way. Oh, yeah, that was also what I was going to do. Before I do that, actually, let me just show you a quick concept of how this actually works. Bear with me 1 second. There's a great website called Online Tone Generator, and you can pump as many hertz as you want, all the way up to 20k into any speaker and drive it to oblivion. And this is what I'm going to be using to just give you a demo. So I'm going to put a 5 hertz sine wave through this. So just bear with me 1 sec, and now I'll show you. Okay, so this is the 5 hertz sine wave I was just talking about. You can see it all moving there. Now you get the basic idea. So I'm gonna switch this on and put some real music to it. Hang on. The bass is coming in now. Okay, I'm going to put through this song. This is just a track. It's from Basstronics. It's called I Love You, or Bass I Love You. Sounds pretty gay, but that is rattling. Really heavy. I mean, you can only just hear it, but that's because there's no the panel. I haven't made it yet, but that's my next mission. I'm just gonna do that now. Well, in a bit. Yeah, it's really heavy, man. proper heavy. Anyway, I'm gonna get on the door panel and then I'll do another video of that. I'll just go around the front without trying to cut my head off. Hang on. Gosh. It is really good. Anyways, I'll see you guys around. Cheers for watching this video, hope you enjoyed it. And hold on a minute. Holy jeez. Yeah, hope you enjoyed it, guys. Yeah, it rattles a lot. Yeah, hope you enjoyed it anyway, guys. I'm gonna make the door panel now. Ooh. When it's moving, you don't get none of that rattle. But yeah, there you go. I'll see you guys around.